So multiple choice, topic 3, a little bit of intro to get us rolling on this. Some of it straightforward, but 43, look at 43. The minimum value of the slope of the curve is, okay, so let's stop at minimum value. How do we find the minimum value of a function? What's that? Maybe that would be the second derivative test, but the first start would be if the first derivative is 0, then you either have a min or a max. So I need the first derivative, and then I'll check to see if it's a min or a max. But this one says the minimum value of the slope of the curve. Well, how do I find the slope of a curve? Take the derivative. So I need the minimum of a derivative. So this is a weirdly worded question. So I want the minimum of, let's see, this derivative would be 5x to the 4th plus 3x squared minus 2. And to avoid the trick with all the derivatives going on, I'm just going to call that something else. I'm just going to call that f. I want the minimum of f. So now I can kind of throw away this first part and work this like a regular problem. So I need to take the derivative of f, find the critical point, and then see if they're mins or maxes. So f prime is 20x cubed plus 6x. And this is no calculator, so I'm making the value should work out here. Alright, so if I set that equal to 0, I can factor out a 2x. 10x squared plus 3. Oh, this is going to work out okay. I set them both equal to 0. 10x squared plus 3 is never going to be 0. Because if I subtract 3, then I've got x squared equals negative. So that doesn't add anything. So x equals 0 is my only possible critical point. The minimum value, the slope of the curve. Okay, so I don't want to plug 0 into this. I want to plug 0 into its slope, which is there, which is negative 2. It's a great AP problem in that the computation math part really wasn't hard. Like the derivatives even weren't hard. The math wasn't hard. It's just understanding when they threw 2 slope words at you or 2 derivative words at you. Minimum means take a derivative. Slope means take a derivative. So yeah, we ended up taking a second derivative. And the last thing I want to comment on, by the way, I don't know if you remember, but you've seen those. That picture was on a test we've had. Yes, maybe you remember it, maybe not. I think 61 might have been as well. What I want to review quickly is 63, 64. Mean value theorem. The mean value theorem is basically that the calculus slope equals the algebra slope. Right, so you take a derivative and you set it equal to good old algebra 1, y2 minus y1 over x2 minus x1. And I guess the conclusion is that where that happens, C is between A and B. So for this one, it would be 1, 6. So your answer has to be between 1 and 6. effect. Because of that, I can throw this. It's not plus or minus square root of 6 because it can't be negative. And you know what? 6/7 isn't on the interval either. So he's out. So it's either A or C. And without working the problem at all, I'd guess A, because my guess is when you work the problem, you get D, and then you have to remember to throw out the negative one and end with A. I don't know. It might actually be C, but if I'm just guessing, if I'm short on time, I'm marking A and moving on. But I don't know that for sure. 64 is a little bit different. I mean, it's kind of it's similar, but instead of asking you where it happens, it just says how many values are there where it happens. So you set the derivative equal to the slope and figure out how many solutions there are. And be careful again, how many solutions on the interval. If I was guessing, there's probably some that aren't on the interval. All right, so that gets you started, so you can spend the rest of the time working together on this. We'll answer questions from this tomorrow, and then you'll have time tomorrow to finish up whatever you need to from the packet. Again, this packet is due Monday, and the video is due by Sunday at 11:45 p.m. It lets me pick 12, but if you pick 12 a.m., is that Sunday night or is that Saturday night? I wasn't clear, so I went with 11:45 to make sure we got it right. Plus, you're all in bed asleep by 11:45 anyway, right? Yes, of course you are.